There's this one equation that's so famous, so iconic, it's pretty much a symbol for genius itself. But behind those five little symbols is a story of a complete revolution. A story that starts not in some fancy university, but in the mind of a young patent clerk and ends up giving us a totally new way to understand space, time, and the very fabric of the universe. So let's pull back the curtain on the world's most famous equation.
And there it is. E equals mc². You've seen it everywhere, right? On t-shirts and movies, you name it. It looks so elegant, so simple, but it holds a secret about how the universe works that is just unbelievably profound.
Because this is way more than just a formula from a physics textbook. It's the climax of a huge scientific detective story, a radical idea that completely turns centuries of science on its head. So how in the world did we get here?
All right, so to really wrap our heads around this, we first have to understand what it's actually saying. What is the incredible secret hidden inside these five symbols? Okay, get this. This one little equation completely redefines what stuff even is. Before Einstein, scientists saw mass, the physical substance of things, and energy as two totally separate things. This equation proved they're basically the same thing. Mass is just a super concentrated form of energy. They're two sides of the same cosmic coin. And the amount of energy that's locked away inside even a tiny bit of mass is, well, it's staggering. That c² part of the equation, the speed of light squared, is a ridiculously huge number, and it acts as this massive conversion factor. To put it into perspective, just 1 gram of matter, that's about the weight of a paperclip, is equal to 90 trillion joules of energy. That's enough raw power to turn 39,000 tons of water into steam. And it's locked inside all matter, just waiting. So, who was the mind that unlocked this incredible cosmic secret? Well, to find him, we have to jump in our time machine and go back to 1905, to what scientists now call the Annus Mirabilis, or the miracle year. And this is where the story just gets amazing. The person who redefined reality wasn't some tenured professor at a big-shot university. No siree, he was a 26-year-old guy working as a technical expert at the patent office in Bern, Switzerland. His day job was literally just reviewing other people's inventions. And yet, in his spare time, this venerable federal pen pusher, as he jokingly called himself, wrote and published 4 papers. Now, any one of these papers would have been enough to make a scientist's entire career. One explained the photoelectric effect, another proved atoms were real, a third laid out his special theory of relativity, and then a short follow-up gave us the seed of E equals mc². All of that in a single year? It's just unbelievable. So it was in that 4th paper, kind of like a little add-on to his work on relativity, published in the fall of 1905, where the real magic happened. It wasn't some long, complicated beast of a paper. Instead, it all started with a deceptively simple question. That was the title of his paper. He was basically asking, hey, if an object gives off energy, does its mass actually change? Now, at the time, everyone would have said, no way. Mass was mass. It was constant. Energy was something else. But Einstein, he thought differently. And here's a fascinating little piece of trivia for you. The famous equation didn't actually show up looking the way we know it today. In his original paper, he wrote it out as this sentence. He used L for energy and V for the speed of light. But the meaning? Whoa, the meaning was crystal clear and absolutely world-changing. This is the part that really messes with your head. Think about it. Light has no mass. So how can an object that shoots out something massless get lighter? It doesn't seem to make sense, right? But that was the core of his discovery. The energy carried away by the light had to come from somewhere, and it came directly from the object's own mass. But Einstein knew his work wasn't done. Not by a long shot. His 1905 theory of special relativity was a total masterpiece, but it only worked for things moving at a constant speed. It didn't deal with acceleration, and it left out the biggest force in the whole cosmos, gravity. So he spent the next 10 years on this incredible intellectual quest. And the result, which he published in 1915, was his general theory of relativity, a complete reimagining of gravity that would become the foundation for all of modern cosmology. You see, for centuries, the world saw gravity through Isaac Newton's eyes, like it was some invisible rope pulling things together.
Einstein's theory just threw that entire idea out the window. He said gravity isn't a force at all. It's a property of the universe itself. It's the bending of the four-dimensional fabric of space-time.
And this new view, the sun isn't pulling on the Earth. Instead, the sun's incredible mass and energy create a deep curve, like a bowling ball on a trampoline, in the fabric of space-time. The Earth is just following that curve, like a little marble rolling around the dip. Mass and energy tells space-time how to curve, and the curvature of space-time tells objects how to move. It was a complete paradigm shift.
Now, I know what you might be thinking. This all sounds incredibly abstract, right? Like something that only matters to astronomers and physicists. But the truth is, Einstein's theories have a really profound and super practical impact on our everyday lives.
I mean, the whole concept of nuclear power comes directly from mass-energy equivalence. Our ability to understand things like black holes, to actually detect ripples in space-time called gravitational waves, and to build our models of the expanding universe, all of it flows directly from general relativity. But there's one application you probably use every single day.
That's right. The GPS in your phone only works because it accounts for Einstein's theories. The satellites orbiting Earth are moving incredibly fast, so special relativity comes into play. They're also in a weaker gravitational field than we are, so general relativity applies too. Without making constant adjustments for these relativistic effects, your GPS would be off by several kilometers every single day.
So, from a simple thought experiment in a Swiss patent office all the way to the phone in your pocket, Einstein's ideas completely rewrote the rulebook for the cosmos. It just makes you wonder, doesn't it? What accepted truth of today is just waiting for the next miracle year to come along and be completely overturned? What fundamental discovery is just around the corner?